All right, so let's go to day 2 of 6.6, and this is function operations and a little bit more. So we've done add and subtract, multiplying and dividing. That was what the last lesson was. And now we're going to do something that's a little bit trickier, but it's not too bad. It's called composition of functions. So whenever you're doing this, you are combining two functions. You're like putting one inside of another and then manipulating it from there. So there's a few different ways you can write it. Here is one way, right here, and you say, all of them are pronounced the same thing, f of g of x. So you can write it this way, you can write it this way, so f of g of x still. And then the other way that you'll probably see, I think, on the homework is, it's like the first way, except it has some parentheses. So f of g in parentheses of x. And yes, I know it looks like fog, but it's not. Another thing to note whenever you're doing these, it looks similar to the multiplication problems that we did on the last lesson, except for this time, last time the multiplication was closed dot. Whenever it is an open dot, you're going to be doing this composition of functions. Okay, so let's actually do some problems. I did change it from what was given, so I changed it to this. So if you don't have this on your paper, please write it down. So we have f of x, okay, equals 4 of x, and g of x equals 6x plus 2. So what you do on this is you take the second function, so g of x in this case, and you plug it in to the first. So I'm going to take all of this, the g of x, and plug it in to the f of x. Okay, doesn't sound too bad, right? Or maybe it does, I don't know. So this would be 4, right? And then we're going to put in for that x all of that other stuff what the g of x actually is. So it looks like that. All I did was take that stuff from the g of x and plug it in for the x in the f of x. All right, now we need to clean it up. So I'm going to distribute that 4, so that gives me 24x plus 8. Can I solve it anymore? The answer is no, you cannot. So this is your answer. Okay, here's another one. So this time we're doing the f of x, so you're plugging in all of the, oops, that's not a highlighter, all of the f function into the g function. Okay, so you're plugging in all of this in for this x right here. Let's do it. So I have 6, sorry, I'm trying to get it together, times whatever the f of x function is. In this case, it's 4x. And then I have that plus 2. Okay, so that gives me 24x plus 12. And that's it. All right, next one, we have h of g. It's not hog. I know it looks like it, but it's not. Of n. So how you say it is h of g of n. I know it's weird. Okay, so this one's a little bit trickier, but not too bad. So you're doing the same thing. You're plugging in the second one into the first. So I'm putting all of this in for this variable right now here. And we have n's this time instead of x's, and they show that right here. No big deal. It's still a variable. You do the exact same thing. But this one is a little bit different. So when I plug that in, it's going to be the 3n minus 4. And since in the h of n, the whole thing is being raised to the second power, I need to raise that to the second power. Okay, so now that gives me, I'm ready to clean this up. Since this is a binomial, we're going to have to rewrite this as 3n minus 4 times 3n minus 4. And then bring down that plus 3. And the only reason I did that is because it's a binomial. I can't just square it straight up as we normally would. Okay, now let's go ahead and keep going. So we got to distribute this 3n. That would give me 9n squared. 3n times -4 is -12n. Now we're ready to distribute the -4, so that gives me -12n right there. -4 times -4 is +16. And then I'm going to drop down that +3 on the outside. Alrighty, now let's clean it up and write it in standard form. So I'm going to write my 9n squared first because that has the highest exponent. And then combine my n's. -12n minus 12n would give me -24n. And then my constants, +16 plus 3 gives me +19. And we did it. All right, let's do another one. So here we go. On this one, it is g of h of n. So g of h of n. So this time you're plugging in the h into the g. Okay, so plugging in this whole h into the g. So let's do it. We've got 3 times, and then we're going to write that whole h of n function, so n squared plus 3, and then you still have that -4 to bring down. All right, so now let's clean it up. I need to distribute this 3, so that would give me 3n squared plus 9 minus 4. Combine your like terms, and I have 3n squared plus 5. And that's it. 2 more. Okay, so this one's probably is as tricky as it's going to get. No big deal, we can do it. So I need to find f of g and g of f, so I'm going to do e first. So let's do f of g. So you're finding the g and plugging it into the f. So we're taking this and plugging it in for here, but you need to be careful on this one because there's 2 different places that they have a variable in f of t. Okay, so let's do it. I've got 2, so 2 times, and then I'm going to plug in that whole g thing, so 4t minus 8, and that t is being squared, and then plus 3 times the g of t again, so 4t minus 8. All right, now I have a lot to clean up on this. So go slow, take your time. I'm going to do the left side first. So 2, and then this is going to be 4t minus 8 times 4t minus 8, because that binomial is being squared. And then I'm going to work this out. So I'm going to FOIL before I distribute in this 2 right here. So let's FOIL first. So I've got 4t times 4t gives me 16t. 4t times -8 is -32t. -8 times -4t is -32t. -8 times -8 is +64. And don't forget, I still have that 2 on the outside, so I need to keep parentheses around it for now. All right, so we have some options. We can either distribute in that 2, or we can combine like terms. I'm going to choose to combine like terms first. It doesn't matter which way you choose, but that's what I'm doing. Ooh, I see I made a mistake. This right here is 16t, should be 16t squared, because it was 4t times 4t. You probably already caught that. All right, so now I still have my parentheses, so this would be 16t squared, dropping that down. Combine your like terms, that gives you -64t. And then drop down that 64. Now I believe I'm ready to distribute that 2 in. Okay, so 2 times 16t gives you 32t squared. 2 times -64t, that would be -128t. 2 times +64 is +128. Okay, that's kind of gross, but it's doable. You just got to go slow and take your time. All right, now let's do the left side. It's a lot easier, don't worry. So all I need to do is distribute this in, and then I'm going to bring it down to the bottom. So positive 3 times 4t gives you positive 12t. Positive 3 times negative 8 gives you negative 24. All right, now I have everything distributed. Now we just need to write it in standard form and clean it up. So I'm going to write the 32t squared first, because that's the first thing we need to do for standard form. Then I have my t's. I have negative 128t and a positive 12t. What would that be? Negative 116, I believe. Yeah. T. And then I have positive 28, or 128 and positive 128 and negative 24 would give me positive 104, I believe, if I did that math in my head correctly. Okay, that is it for that problem. So let's box it, and we're done. We just have one more to go. I think this one's a little bit easier, so don't worry. Okay, so this time we're plugging in the F into the G. So taking this whole F and plugging it in for that G. This one is definitely going to be easier. So I have 4 times 2t squared. Oops, I'm changing colors. I'm trying to be good with my color coding on this. So 2t squared plus 3t. And then I have a minus 8 that I need to drop down. All right, this one's a lot easier than the last one. We need to distribute this 4. So that would give me 8t squared plus 12t minus 8. Let's clean it up. Okay, look, there's nothing to combine, so there's no like terms that you can combine. It's also already in standard form. That was nice. So we're done. All right, that is it for this video. Thanks for watching, and have a great rest of your day. All right, so let's start 6-7 part 1, and this section is all about inverses. So the inverse of a relation and or function is when the domain, oops, I don't like that color, let's try again. The domain and the range are switched, or the x and the y are switched. And you need to know that. That is a quiz question. They're going to ask you, what is an inverse? Okay, so you switch the x and the y. So how you say it, I know it looks a little crazy. It has an f to the negative 1 power, and how you say it whenever you see that negative 1 power on that is you say the inverse of f at x. So the inverse of f at x. It's kind of weird, I know. If you're finding the inverse of an equation, which is what we're doing in this first part, it's 2 steps. So you switch the x and the y. Remember, if you have f of x, that's the same thing as y. So you switch them, and then you solve for the new y, which means you get the y by itself. Okay, so let's talk about a function. So, well, first we'll go back to a relation. So a relation is anything that you can graph. It's a graph, equation, tables, points, ordered pairs. It could be anything. So everything that can be represented graphically is a relation. Okay, a function is where each input has exactly one output, which means, I like this, there's no repeating x's, and it passes my favorite, the vertical line test. So, for example, we have a bunch of different examples of a function. So this line would be considered a function. You could have a parabola would be one, a square root would be one. Let's see, you could have something crazy that looks like this, right? It would still be past the vertical line test. You could have a bunch of points. As long as no points would fail the vertical line test, it's still a function. Okay, so an example of not functions would be, let's see, something Oops, that's right, wrong. Let's try a vertical line. That would not pass the vertical line test, right? It would definitely fail. You could have a circle. That would fail. You could have a sideways parabola. That would fail. You could have dots with at least one that would fail the vertical line test, or one set. Okay, so that's the difference between functions and not functions. That's what we did at the very beginning of the school year back in Unit 1 as we talked about functions. So I'm actually going to skip this graphing part right now, but we're going to go to solving algebraically. So find the inverse of each function. Is the inverse a function? Okay, so I want you to find the inverse and then tell me if it is or is not a function. So how do you do that? So you're going to switch the x and the y. Okay, everything else stays the same. So all I did was switch the x and the y, and now I need to solve for the new y, or get it by itself. So in order to do that, I would need to add 1. So I have 2y on the right side because those cancel. And over here on the left side, I have x plus 1 because we can't add those together. They're not like terms. Okay, so now I need to get the y by itself. Last thing, I'll need to, how do you get that 2 off of there? Well, you need to divide it. So divide by 2. That cancels. The y is then by itself, right? So then it would be x plus 1 over 2, because you can't simplify or can't reduce it because that's a binomial on top. And so that's as far as you need to get. Another way you could write this that might help you answer this next part, algebraically, I'm actually going to take that box off. Sorry. All right, so I'm going to take that box off. You could write it as y equals, remember that x has a 1 in front of it, so you could write it as 1 over 2x plus 1 over 2. Okay, so either one of those is perfectly okay. Let's talk about why I did this one. So this should probably look more familiar to you than the top one. They are the same thing, but that one on the bottom is something that's a line in slope-intercept form. The y equals mx plus b. So this would be your slope, this would be your y-intercept. So why I did that is because the second part of this is the inverse a function? Well, is that line a function? Absolutely. All lines are a function with the exception of a vertical line. So this is, yes, it is a function, and you do need to have that on there. Let's do another one. Okay, so writing the inverse again, first step is to switch them. So I have x equals 5 minus 2y squared. All right, so let's get the y by itself. I think first thing I would need to do is, there's a few different ways to look at this one, but I'm going to minus 5. So I have x minus 5 equals negative 2y squared. Okay, so then let's divide by negative 2. Divide by negative 2. So then I have y squared, because those cancel. And then let's go ahead and break this up into, I'm going to break it up into negative 1/2 x. And then negative 5 divided by negative 2 would be positive 5 over 2, or you could say 2.5, it doesn't matter. Okay, now we need to square root it to get that y by itself. So square root it. So we have y equals the square root of negative 1/2 x plus 5 over 2. Okay, is this a function? Yes, it is. This is just a square root problem, and you know that square root problems, they are going to look something like this, right? Is this a function? Yeah. I know this negative may be tripping you guys up in here, right there. Don't let it bother you. It is perfectly okay. Alrighty, let's do another one. Switch them. So we've got x and y. Put the rest of this stuff in. So I'm going to add 5. So x plus 5 equals 3y squared. Okay, now we need to get the y by itself. Let's divide by 3. So y squared is, I am going to break this up into 1/3 x plus 5/3. You really don't have to, it's just a personal preference. Now what do I need to do to get that y by itself? Square root. So you have y equals the square root of 1/3 x plus 5/3. Is this a function? Yes, it's another square root function, so it is. Okay, now let's do this one. Switch them. Okay, this one's a smidge different, but it's okay. What do you need to do first to get the y by itself? Well, since there's parentheses right there and it's being squared, you need to get rid of those parentheses in that square. So I'm going to square root both sides because that would cause it to go away. So now I'm left with 3y minus 4 equals square root of x. Okay, so now what would I do to get the y by itself? I would need to add 4 to both sides. So now I have square root of x plus 4 equals 3y. Last step, divide both sides by 3. So I would have, you could write that square root of x plus 4 over 3, or you could say 1/3 square root x, right? That would work, plus 4/3. And I like to go to that form because that's the way we know how to graph it. And is that a function? Yes, it's still just a good old square root graph that everybody loves. All right, so we're gonna add a few more. If you don't have these on your paper, go ahead and add them now. We got 6 more to do. I'm sorry, but you need the practice. So for the function, find f prime, or the inverse of f at x. Sorry, sometimes you say f prime. Okay, so let's solve. So here's the first problem. So remember, f of x is just a fancy way to write y. So I'm going to switch them. So okay, what do I need to do? Oh, I forgot the 1/5 right there. Okay, what do I need to do to solve for x? Well, I need to take the 5th root of that to get that parenthesis and those exponents off. So it would be the 5th root of x on both sides, or 5th root of both sides. So now I have 5th root of x is equal to y plus 8. To get the y by itself, I would just need to subtract that 8 off. So I'd have y equals the 5th root of x minus 8. And you don't have to tell if this is a function or not. You're just doing it. Okay, here's the next one. So remember, that is a y. So let's go ahead and switch them. Okay, what do I need to do first? Add 6, add 6. I have x plus 6 equals the 5th root of y. Get that 5th root off that y, so I need to raise both sides to the 5th power, because that's the opposite of 5th root. So this gives me y equals, and I don't want you to FOIL that out, it would be a nightmare. So we'll just leave it as x plus 6 to the 5th power. Okay, next one. Let's go ahead and switch. Okay, this one's a little different. What would you do first to get the y by itself? Well, I need to get rid of that 7 out of that denominator. So how do I do that? I need to multiply both sides by 7. So those will cancel. So now I have 7x equals y minus 7. Then it's no big thing. Just add 7. Y would equal 7x plus 7. Here's D. Let's go ahead and switch them. Okay, what do I need to do to solve for y? Try this one by yourself. Pause the video. So I'm going to square them both. So since that's only one thing on the left, that's just x squared equals y minus 10. Add 10. Y is equal to x squared plus 10. 2 more. This one's a little weird, but it's okay. So we have x, y switched. Okay, this one. What do you think we do first on this one? If you notice, there are no parentheses on the right side. So if there were parentheses right here, then we would just take that to the 3rd power. But since that's not the case, we have to get that 10 off of the y to the 1/3 first. So we're going to divide by 10, divide by 10. So x over 10 is equal to y to the 1/3. Now I need to get that 1/3 off, so I'm going to raise it to the 3rd power. So you could either write it as y equals, in parentheses, x over 10 to the 3rd, or if you wanted to write it as x to the 3rd over 1,000, because that's what 10 to the 3rd is. Either one of those is perfectly acceptable. Last one, go ahead and switch them. Okay, so we need to get rid of that 6 outside of the parentheses first. So I'm going to divide it off. So I have x over 6 is equal to y minus 2. Then we need to add 2. So I'm going to have y equals x over 6 plus 2. Just for fun, what's another way you could write that? 1 over 6 x plus 2. And why did I do that? Because the bottom one is the equation of, they're both equations of the line, but the bottom one is an equation of a line in slope-intercept form. So that is it for this lesson. Thanks for watching. Have a great rest of your day. Recap on a few things about special right triangles. So I know we did this back in part 1, so it's been a while, a few months, but we just need to kind of refresh these properties because you will use these in this lesson. So let's first talk about the 45, 45, 90 triangle. So this is a triangle where it is an isosceles right triangle. So that means these two legs are the same. I'm going to call them x. And do you remember what the relationship was between the legs and the hypotenuse was? It was x times square root 2. Okay, so this is something that I would suggest writing on your cheat sheet because you can use it later. Okay, so now let's do one of these. So we're going to find out the other two missing sides. We know it's a 45, 45, 90. So these two are going to be the x, and this is going to be the x times the square root of 2. Okay, so this side over here must be 2 because they're the same, right? And so then for this, our x is 2. So then this hypotenuse must be 2 times square root 2. Okay, not too bad, right? Let's do another one. So now the hypotenuse is 5 square root 2, so I'm going to label them x, x, x times square root 2. So we're trying to figure out what the legs are. Well, how do we get from hypotenuse to the leg? Well, we're going to have to divide this to get it to just be x by the square root of 2. So I'll do it off to the side. Oops, that's a 2. So it'd be 5 square root 2 divided by 2. Divided by the square root of 2. Those cancel because we're trying to get that square root of 2 off of there. So this would just be 5. Right? That makes sense. If the x is 5, then the hypotenuse would be 5 times square root 2. Right? Now, here's the hardest level one. I don't know if you'll see very many of these in your homework and stuff today, but I'm going to do it anyway. So, again, how do you get from the hypotenuse to the leg? So I'll label it so it helps a little bit. So how do you get from the hypotenuse to a leg? You divide that by the square root of 2. Okay, we need to get that square root of 2 out of the denominator, because if you remember back to our rules, you cannot leave a square root in the denominator. How you do that is you multiply it by itself. And whatever you do to the bottom, you must do to the top. So then this would equal 7 square root 2 over square root of 2 times square root of 2 is just 2. All right, let's check. Can we reduce this? So when you're looking to see if you can reduce it, you look at the two non-square root numbers, because you can't reduce square root 2 and a regular number. Okay, so the answer is no, you can't reduce it. So this x is going to be equal to 7 square root 2 over 2. That's how you say it. I know it's a mouthful. And so is the other one. All right, now the next special right triangle was the 30, 60, 90. This one is also very useful. So on this ratio, if you don't remember, the shortest side is your x, always. So it's the side next to the 60-degree angle. The hypotenuse is 2 times the x, and then the other leg is x times the square root of 3. Okay, so it always basically how I do all these problems is I figure out what x is, and then I can find the other side. Okay, so here we go on our first problem. They give us the short side, so I'm going to rewrite my ratios. I think it's helpful. So this would be 2 times x. This would be x times square root 3. All right, this x is 3. Okay, so that's no big deal. The hypotenuse would be 2 times our x value, which we just said was 3, so 6. And then this leg would be our x, so 3 times square root 3. And you can't multiply those, so you just leave it just like that. All right, oops, I switched this around. Sorry, I'm going to change this to be, this 8 needs to be over here. I set this up wrong. Okay, so now we're ready. So it's going to be x, 2 times x times square root 3. So find out what x is. So if this hypotenuse is 8 and that's 2x, what would x be? That would be 4, right? You have to take it off, cut it in half. Okay, so now we have our x. So then this would be 4 times square root 3 over on that leg. Okay, this one I also need to change, sorry. So I meant to put that on the other side. This one's the last one we're going to do of these. So then this is x, 2 times x times square root 3. So then we're going to make this one 5. Oops, sorry. 5 square root 3. Okay, so let's figure out what the x is. If that's 5, or x square root 3 and 5 square root 3, then our x must equal 5, right? So then what would the hypotenuse be? It would be 2 times 5, which gives you 10. Okay, now that I've wasted 6 minutes of your time, let's get in. All right, so before we actually get into 10.2, I want to do the actual lesson. Here it goes. So we have area of a trapezoid, rhombuses, and kites today. So a trapezoid, here is the formula. It's on your cheat sheet. It's 1/2 times your height, h is height, and then parentheses, base 1 plus base 2. So this is base 1 and this is base 2. Something to note is whenever you're doing these, your bases are always the parallel sides. Okay, sometimes it's hard to see them. So the B1 and B2 is always going to be the one set of parallel sides. Okay, so so how this is a trapezoid. All right, so we are going to write our formula so we get all our points. So area equals 1/2 times height, parentheses, base 1 plus base 2, close parentheses. Alrighty, so what would our height be? So our height on this one is 309. That's the distance between the two bases. So that's going to be 309. Parentheses. Our bases are these two lines, the parallel sides. So that would be 205 plus 511. All right, go ahead and type that in your calculator just like that. Please type it in your calculator so you can practice. Pause the video if you need to. All right, so I just paused the video and typed it in my calculator, and I get 110,622. Sorry, I struggle with that number. So there's our third point with the correct answer, and your fourth point is your label, so miles squared. Alrighty, now this next problem, another trapezoid. It's not going to be quite as easy. Hold on, I'm going to pause this and erase some of that stuff. Okay, so what is the area of this trapezoid? They give us the two bases, right? We know this and we know this are the bases. Our problem is we need this distance right here because that is our height of this trapezoid. We need height for the formula. So, do you have any ideas of how to find the height? Let me give you a hint. So I'm going to draw a line right here. That's still the height, RQ. I just shifted it over. But if you notice, I have a 30, 60, 90 triangle. Weird. I just talked about 30, 60, 90s. So this is our 30. Okay. So I'm going to write the ratios to kind of help myself. So I know this is X, this is X, 2X, and this is X times the square root of 3, right? The other leg. Okay. Can I figure out what any of the sides are? The answer is yes. I can figure out what X is. So I know this side right here is going to be 2. And the reason I know that is because this whole thing right here on the top, SR, is 5. And the whole thing on the bottom is 7. So I got to do that 5 piece, which is right here, minus the whole piece, 7, and I get 2. Okay, so now I'm ready to do the rest of it. So this would be 2 times my X, which would be 2. So then that piece is 4. And then this other piece is 4 times the square root of 3. Okay, I believe I have all of the pieces I need. So I'm going to write my formula, 1/2 times height, parentheses, base 1 plus base 2. All right, if you notice, there is one number in here I do not need, and that is this 4. I didn't need to do that step. I did it just for fun, but really that's not the bases, that's not the height, so I don't need that for this problem. So here we go. I'm going to have 1/2 times my height, which is kind of weird, but it's okay. It's 4 times the square root of 3, parentheses, base 1 is 5, plus, what is base 2? Well, it's the original amount, the whole thing, so that would be 7. All right, so now you're going to type this in your calculator and round it to one decimal place. All right, and I just did it, and I got 41.6. Okay, and then let's get our label on there, meters squared. All right. So we're going to skip that, go to the next slide. We're talking about rhombuses and kites. So here is the formula for a rhombus and a kite. They have the same formula, which is convenient. So this is also on your cheat sheet right underneath the trapezoids. So it is 1/2 D1 times D2. Okay, D's. The D's on this are standing for diagonals. So D1 is this in the blue, D2 is in the red. The order doesn't matter which one's D1, which one's D2, because we're going to be multiplying them, and in multiplication, the order does not matter. So let's just go on before I go to that. Let's go to kites. Kites have the exact same notation, or the same formula, D1 times D2. So they have the same formula. All right, here's what to notice on rhombuses. So when you were doing rhombuses, the diagonals bisect each other. If you remember that from Unit 4 or Unit 5, I believe. So what that means is this piece and this piece, or that blue diagonal, is to cut into 2 equal pieces. And then the red diagonal is also cut into 2 equal pieces that are different from the 2 blue ones. But just remember that whenever you have diagonals of a rhombus, they're going to be cut into 2 equal pieces, and that's something you're going to have to use here in a bit. Okay, and then a kite. Here's our kite. And this obviously isn't cut into 2. Both of these diagonals are not cut into equal pieces, but the short diagonal, the D1, this one is. So this piece and this piece are equal. You probably won't have to use that as much, but maybe. And then the long side of the kite is not obviously cut in half. Okay, so what is the area of the kite? KLMN. So we got our formula. Area equals 1/2 times D1 times D2. All right, I am going to make D1 be this amount right here. So what would that be? So I'm going to have 1/2 times, well, that is going to be 3 plus 3, so 6. And then I'm going to have D2 be this distance right here. And what would that be? Well, that's going to be 7. Okay, now let's do our formula. So 1/2 times 6 times 7, I believe, would be 21 meters squared. And that's it. Okay, this one's going to take a little bit more work, so stick with me. Please don't give up. Please write all this stuff down because you have some problems coming up like this in a little bit. Okay, a rhombus has sides 10 centimeters long. If the longer diagonal is 16 centimeters, what is the area of the rhombus? Word problem, gross. We're going to have to draw a picture. Okay, so draw your best rhombus. Mine's going to look something like this. And so we know, since it's a rhombus, all 4 of the sides are going to be congruent. All right, so now let's draw the diagonals. Do a red and a blue like the notes did. Okay, so it's saying the longest diagonal, I'm going to call that the red one. That whole distance is 16. Okay, so and then the sides of the rhombus, the outside sides are 10. So this is 10, this is 10, all of these are 10. Okay, so if that whole red diagonal is 16, then half of it would be 8. Because it's cut into 2 equal pieces. All right, another thing you might remember about rhombuses is their diagonals are perpendicular, so they make right angles. All right, looky there, we have a right triangle. So we need to figure out, we're looking for what is this, because we know that's half of that other diagonal, which is what we need. So we'll find that and then double it, and we'll have both of our diagonals and ready to do the formula. Okay, which do we do? Or what do we use to find this formula, or this diagonal? Can we use 45, 45, 90s, 30, 60, 90s? The answer is no on both of them, and the reason why is because they don't tell us how many degrees those angles are. So we can't use that. So how do you find out a side of a right triangle if you have two of the sides? It's the good old faithful Pythagorean theorem. So a squared plus b squared equals c squared. Okay, which one must be our c? That's 10. And I'll make a be our missing side. So I have a squared plus, that would be 64, equals 100. So minus 64 minus 64. A squared would equal, that's 36. The last step is to take the square root of that. So a is 6. Cool. So this side right here is 6. Yes, I know we did all that work. 6 is not our answer. We're still trying to find the area. We just had to do work in order to find it. So we've got our formula. We're writing that. 1/2 d1 times d2. Okay, let's make d1 be the red diagonal. Well, how much is that red diagonal? It is 16, right? 8 plus 8. And then I will make d2 be the blue diagonal. How much is that? That's 6 plus 6, so 12. Okay, now when you do that math, you end up getting 96. Okay, and what is our label talking about in this problem? Centimeters squared. Okay, so that is that problem. Last one, the high occupancy vehicle HOV lane is marked by a series of diamonds. So this is in bigger cities. I've seen it in Dallas, Chicago, Las Vegas. So this is, it's on the interstates usually, and it's whenever you get into this lane, you have to usually have like 2 or more people in your car. You have to stay on it for a while. You can't change lanes and exit, and people usually move pretty quickly. The speed limit's a little higher usually. And it's supposed to help promote traffic and that stuff. But, all right. So anyway, long story short, this is a rhombus. Okay. What is the area of the HOV lane painted below? So we need the diagonals. So it looks like we have this right here is 2.5. So that means this is 2.5. And I'm sorry, this is hard to see on this drawing because this is so dark, but it is what it is. So I'm going to say this is 2.5, right? Because it is. So I know that diagonal, but the problem is I don't know the other diagonal. So we need to figure that out, and I think we can do it. So we need to figure out what this is. How am I going to have to do that? Well, since they don't tell us anything about the angles and how many degrees they are, our only option is Pythagorean theorem, exactly like the last one. So we have a squared plus, I'm going to make 2.5 be the b, equals 6.5 squared, because that's your c. So a squared plus, I know that's 6.25. I got to put the other one in my calculator. 6.5 squared would give me 42.25. Okay, now let's subtract 6.25, subtract 6.25. So I have a squared equals 36, I believe. Square root. This is a coincidence. A is 6. They're not always 6. It's just coincidence on these last 2 problems. So that's 6. That must mean this is 6 as well. All right. That wasn't too bad. Now let's do our diagonals, or our formula. So we have 1/2 times d1 times d2. So 1/2, I'll have d1 be my yellow, the horizontal line. 2.5 plus 2.5 would give me 5. Times d2 is 6 plus 6, so 12. All right, and that gives you 30. And what's my label going to be? Feet squared. All right, that is it for this lesson. I'm sorry it was so long. Thanks for watching and have a great rest of your day.